Hi, good afternoon, everyone. So, beta, today we are going to go ahead and take ISI PEA 2005 question 5 to 8. Let's look into the question. So, it says alpha and beta are roots of the equation. The equation is given as x square minus px plus q is equal to 0. And we know that the sum of the roots is going to be minus b by a. So, it is going to be p. And the product of the roots is equal to c by a. So, it is going to be q. Now it says define the sequence xn is equal to alpha to the power n plus beta to the power n. So what you can go ahead and you can do is you can just try to find out what is going to be x1 from here. So x1 will be alpha to the power 1 plus beta to the power 1. So alpha plus beta, which will be p. Now, if I find out x2, it is going to be alpha to the power 2 plus beta to the power 2. So I can write this as alpha squared plus beta squared plus 2 alpha beta minus 2 alpha beta. I can add and subtract 2 alpha beta from it. So this is going to give me alpha plus beta whole square minus 2 alpha beta. And alpha plus beta is p. So p square minus 2 alpha beta. So this is going to be p square minus 2q. P square minus 2q. Okay, if here I go ahead and I find out what will be x to the power 0, I mean x0. This is going to be alpha to the power 0 plus beta to the power 0. Anything to the power 0 is 1 plus 1. So this is going to be giving me 2. Right. So I can replace this 2 with x naught here. Right. And I can go ahead and I can just write this p into p minus x naught into q. And I can replace this p with x1 here. So I will get p into x1 minus q into x naught is equal to x2. So if I were to go ahead and I were to generalize this thing, I could have formed a generalization that if I take n here, this will be xn minus 1 here, and this will be xn minus 2 here, right? So I have been able to get a general statement here. So this is asking me for n plus 1. I can write it for n plus 1 also. So n plus 1, n and n minus, right? So I will get xn plus 1 is equal to p xn minus q xn minus 1. A. That's the answer to this question. Okay, beta. Okay, let's look into the next one. Okay, so this is again a very easy and interesting question. Okay. So this is asking you that you're given a function which is twice differentiable, okay? And the function given to you is this. So it says 2fx minus 3f2x plus 4f of 4x and limit x tends to 0 by x square. So you need to understand that when I talk about this function here, it's given to me that f of 0 and f dash 0 are 0. So if I just directly put 0 here, so I will get 2f of 0 minus 3f of 0 plus f of 0 by 0 square, and 0 by 0 is going to be actually 0, right? I mean 0 by 0 will be not defined. So we have to go ahead and use L'Hopital rule. So in order to use L'Hopital rule, I will get 2f dash x minus 3. So f dash 2x and differentiation of 2x will be 2 plus f dash 4x and differentiation of 4x will be 4 upon 2x and limit x tends to 0. So this is going to give me 2 f dash x minus 6 f dash 2x plus 4 f dash 4x upon 2x, and this is going to be limit x tends to 0. Now what I can go ahead and do is, again, I will try to evaluate this function. So I will put 0 here, 0 here, 0 here. But f dash x is also 0. So the numerator is 0 and denominator is also 0. So it is a 0 by 0 form. So I need to use L'Hopital again. So limit x tends to 0. So 2 f double dash x minus 6 f double dash 2x, differentiation of 2x is 2 plus 4 f double dash 4x, differentiation of 4x is 4 upon 2. Now I need to put the value of f double dash x, and that is given at 0, and that is given to me as 4. So I will just put first x as 0 here. So 2 f double dash 0 minus 12 f double dash 0 plus 16 f double dash 0 upon 2, and that is given to me as 4. So I'm going to plug 4 now. So 2 into 4 minus 12 into 4 plus 16 into 4 by 2. So this is going to give me 8 minus 12, 24, 36, 48 plus 32 into 30 into 2 is 64 by 2. So this is going to give me 64 minus 40, 24 by 2, 12. So the answer to this question is going to be 12. Okay, come to the next question now. So this says, okay, this is a very, very good question. Excellent question. Let's try to see this question. Good one, huh? So this says that you are given log x2 by log x1, and you need to find the relation of log x2 by log x1 with x2 by x1. So whenever we need to do such kind of questions, beta, we need to, so try to see, huh? This is asking whether log x2 by log x1, whether this is less than x2 by x1, greater than x2 by x1, or so on. So can I just go ahead and write this as this? So it is asking me if this is there, or if this is there, right? Or if this is there, right? Or if this is there, something like this, right? So you need to understand that whatever it is saying, it is asked in a way, the core function that I have somehow is going to be x2 by x1. So what I do therefore is I start with a basic function, call that function, that let the function be log x by x. And what I do is I find f dash x. You'll see why. So if I find the derivative of this function, the differentiation of the numerator into denominator as it is, minus the numerator as it is into differentiation of denominator upon denominator to whole square. So this is going to go ahead and give me 1 minus log x by x square. 1 minus log x by x square. And remember that you are given that this is log to the base e, right? You're actually given that this is log to the base e. So if I were to go ahead and I were to plot this function ln x, so we know that this function is going to look like this, and this is 1 here. So we know that log to the base e is going to be negative. It is going to be having negative value as long as x is less than 1, right? So whenever x is less than 1, we know that log x will be negative, right? Now try to see here, beta. So we are actually asking what is going to happen to 1 minus log x. So we know that if x is positive, when x is greater than 1, log x will be positive. When x is greater than 1, log x will be positive. And when x is less than 1, log x will be negative. Am I clear with that part? Okay. Now try to see that this is telling me that x1 is greater than e. x1 is greater than e, right? So therefore, what I can go ahead and do in that case, beta, I can just use that. It tells me that x is greater than e. So I know that log x is going to be greater than log e to the base e. So I know that log x is going to be greater than 1. Log x is going to be greater than 1, right? Now, try to think about this. If I now find out what will be 1 minus log x to the base e, I bring this here, it is going to be negative. It is going to be less than 0. So the numerator is going to be negative and the denominator is positive. So this entire term will be negative. So what we get from here, therefore, is that actually we have f dash x is less than 0, and therefore it's a decreasing function. In whatever is given to you, it is a decreasing function in this case. Now, if this is a decreasing function, if we assume that this is a decreasing function, and we're not assuming, we're proving that this is a decreasing function, this function, log x by x is a decreasing function, then beta, if x1 is less than x2, so what is the property of any decreasing function? If I just plot any decreasing function, so I have x2 here and I have x1 here, x1 is less than x2. So f of x1 will be greater than f of x2. So when x1 is less than x2, so f of x1 will be greater than f of x2. So what we have therefore got in this case is that f of x1 will be greater than f of x2, right? So f of x1 means log x1 by x1 will be greater than log x2 by x2, isn't it? So from here I have got log x1 by log x2 will be greater than x1 by x2, or if I just write this in the reverse way, x2 by x1 will be greater than log x2 by log x1. So we have proof that log x2 by log x1 will be less than x2 by x1, and therefore the answer to this question will be A, right? Okay, beta, come to the next question. Very good question. Again, so why do I say that these questions are good? Because they kind of go ahead and they trick you around the words. So look here, this is the expression given to you. If you notice the expression pattern, it says summation of, if I take this as n, this will be n plus 1. Isn't it? If I take it to be n, it is going to be root of n plus 1. And I'm summing this over. So what I can do is I can just try to rationalize this thing. So I can say this, that this is going to be root n minus root of n plus 1 upon root n minus root of n plus 1. And this will give me root n minus root of n plus 1 upon. So I'm going to use the property of a minus b. A plus b is a square minus b square. And this is going to go ahead and give me root n minus root n plus 1 upon n minus n plus 1. So this is going to give me root n minus root of n plus 1 upon n minus 1. And this will be n plus 1 under root minus root n. Right? This will cancel out, minus will go in the numerator, and this will become this. So now I need to sum this, and my n goes from 1 to 100, and I need to sum root of n plus 1 minus root of n, right? And if I just use the sum here, it is going to be, if I just plug 1 here, then it is going to be 1 plus 1, which means under root 2 minus root 1. Then if I just put 2 here, under root 3 minus root 2, and so on. If I put 100 here, under root of because no, this is going till 99. The last term is 100, right? So this is going till 99 here, right? N plus 1 is 100. Dekho yahan pe. I have taken this as n. So n only goes till 99. N plus 1 goes till 100, right? So this goes till 99. So my last term will be root of 100 minus root of 99. So what will you notice, beta? You will notice that these terms will start cancelling out. Root 2 with root 2, root 3 with next root 3, root 99 with root 99. And you will be left up with root of 100 minus root of 1. That means 10 minus 1. That means 9. So the sum of this entire expression is going to be 9. So if the sum is 9, it means 9 is a rational number. And 9 lies between 0 to 10 because this is an open interval. So I cannot say it lies between 0 to 9. Here 9 is not included. So we can go ahead and we can say that the answer to this question will be C. It is a rational number lying between the interval 0 to 10. And that's the answer to this question. Okay, beta. Thank you.